we're continuing on with 6.9 with solving fractional equations. And what we could do is we could do cross multiplication, but we have to be careful of extraneous solutions. And we'll come across that pretty soon. So a lot of students are really good with cross multiplying, which does work. So if you do 5, just make sure that when you cross multiply, that you multiply by the quantity, so it's 20x plus 25. And same thing as I cross multiply the 2 over here, that we get 2x minus 1. So I'm going to subtract 2x to the left side, and while I'm at it, subtract 25 to the right side. So I'm looking at 18x is equal to negative 26. And from here, when you divide the 18 over, I do prefer my improper, 26 and 18 are both divisible by 2. If anybody's stuck on this, you can use your calculator. But I would encourage you to still understand why the answer is negative 13 over 9, because both 26 and 18 are divisible by 2. We're looking for that kind of answer. Now this one doesn't have any extraneous because the denominator has to be 2 and this denominator has to be 5. But as we look at the next one, what makes this one more complicated is you have two things. You have two binomials, and what you probably need to remember from before is that when you have two binomials is to FOIL. So as I do this first one, you'll see it's x squared. It'll be minus 6x plus 1x, so minus 5x. And then 1 times negative 6 is negative 6. Now the other cross product, it's not two binomials, it's just the 2 that has to be distributed. 2 times 2 is 4, minus 2x. But what you'll see me do is not only will I subtract a 4 over, but I'll also add the 2x over, because I want to get it to be a quadratic equal to 0. So that's negative 10. Negative 5 plus 3 is I knew the answer was negative 3, that's why I said it. But at this point, this factors. So the factors of negative 10 that add to be negative 3 are x minus 5, x plus 2. And so if you recall, our solutions are always the opposite. So positive 5 and negative 2. And again, it doesn't happen in this one, but you might have extraneous solutions, because if you plug in negative 2 in for these x's, you got to be careful if you're dividing by 0. Well, 2 minus negative 2 is 4. We're fine. So wouldn't be surprised, though, if we come across a situation where we do have. Now, the issue that we have with the next one is not so much of the cross multiplying, or that we can't cross multiply, but we can do the least common denominator for all the fractions, just like what we've done before. So in this case, the least common denominator would be 4x for all of them. So the thought process then is I can multiply this first fraction by 2x. 2 times 2x is 4x. So you have to multiply the top by 2x as well. I guess that's all they really wanted you to do is to find it. Now over here is where I'm supposed to do that. But that's okay. 1 times 2x is 2x. This denominator was fine. Same thing, this denominator was fine. So here's the thought process, is if all the denominators are the same, it must be true that the numerators are the same. If the denominators are the same, the numerators are the same. I guess I need to practice English. But anyway, that's the whole theme in this, is a different approach. And then you can just say 2x minus 9 must equal 3. So you can add 9 over. So 2x equals 12. And therefore x equals 6. And you can double check that that's the right answer, because I can go to the calculator and just type in alpha x 1/2 minus, didn't put that in the right spot. Because remember, this is math class. We can always check our work. 9 over 4 times 6, because x is 6. And then see if I get the same answer if I do 3 over 4 times 6. And look at that, we get the same answer They both are 1/8, so it must be true that x equals 6 works. And so we can practice this type of skill where cross-multiplying is not really an issue. So if I look at this one, again, it's the least common multiple. That's how we get the common denominator. And I would go ahead and say that it has to be 30. So getting the denominators to all be 30, well, this one would be pretty easy. You just have to double it. So let's double the top. 31 times 2 is 62. But what makes the other ones a little bit trickier is that you have to distribute. Well, 6 times 5 gives me 30. So I have to multiply the top by 5, and it's the entire thing, 5x minus 20. We still have a plus in the problem, but then I need to multiply the other piece, I'll use green, by 3, and I need to distribute that 3 in there. So we're looking at 3x minus 6. So again, if the denominators are the same, the numerators must also be the same, and I'm going to combine like terms. That it's 8x minus 26 needs to equal 62. So add 26 over. We're looking at 8x needs to equal, let's see, 88. And when you divide both sides by 8, you'll get x equals 11. And feel free to pause the video and rewatch and try to go on from there, because it's only going to get more complicated. So as I look at the next one, I don't know if this is extremely obvious, but you don't have to get the same denominator for everything. What you could do is just get the same denominator on the left side and the right side. But I'm going to go ahead and stick with getting the same denominator for all sides. So 10x squared. I can get the right side to also be 10x squared. So just going piece by piece, trying to color code that 10 times x squared gives me 10x squared. So I have to multiply the top by x squared. 1 times anything is that thing. So the next one I have to multiply by 10x, and 1 times 10x is still 10x. Again, just trying to color code. This next one has to be multiplied by 2x. 5x times 2x is 10x squared, so multiply the top by 2x. And then the last one, kind of running out of colors here, I need to multiply by 10, so I need to multiply the top by 10 to get to 10x squared. And again, if the denominators are the same, the numerators must be equal. And at this point, I would start subtracting terms over, because it is a quadratic. Negative 10x minus 2x is negative 12x. Add the 20 to the left side, and factors of 20 that add to be negative 12 are negative 10 and negative 2. But remember, your solutions have to be the opposite. I'll just jot it down over here, positive 10 and positive 2. Again, you might have extraneous solutions, but the only value for x that wouldn't work would be 0. We can never divide by 0, so these two answers do work. Next one is just a little bit more complicated because we have 5 fractions to work with, and I would definitely want you or encourage you to play around and see why I'm choosing 4x squared when you look at both sides. So just think about it, try this on your own, that you have to multiply this first fraction by 2 to get to 4 and x squared. Then the next one, I have to multiply by a 4 to get to 4 and an x. So 3 times 4 would be 12x. And then this last one, I just have to multiply by 4. Well, 1 times 4 is 4. Same thing with this next one. I have to multiply 4x by x. And then 2x squared, I have to multiply by 2. And then at this point, the denominators are the same, so the numerators must be the same. So what I would do is just subtract 1x over 12x minus 1x would be 11x. And have to subtract 2 over, so it would be negative 6 equals 0. And then we're back to our slide and divide method. 2 times negative 6 is negative 12, which factors would be 12 minus 1. Just remember to do the divide piece. So 12 over 2 reduces to 6. So we're looking at x plus 6, and then just remember to slide back 2x minus 1. and double check that that FOILs out to be 2x squared plus 11x minus 6. And it does. And then our shortcut is our solutions are always the opposite. So negative 6 and 1/2, and again, both of those answers work. It's the only thing x cannot equal is 0. We can never divide by 0. Now, I've been warning you about extraneous roots because I knew we were going to talk about it towards the end. And another reason why this is more complicated is if you look at this fraction right here, or I should call it a quadratic, it does factor to be x plus 5, x plus 3. So as you're looking at all the terms, let me change colors real quick, that's actually going to be your common multiple for all of these. And so as you go piece by piece, this first one, x plus 5, was missing the x plus 3. So I have to multiply the top part of the fraction by x plus 3 as well. So as you FOIL that out, you'll see that you get x squared. I'm doing 2 steps at once. You get 1x plus 3x, so that's 4x. And then 3 times 1 is 3. Now the next piece is actually already fine. It already has all the pieces, so I don't have to change that 18. On the right side, I am missing something. I'm missing x plus 5 to get to my new denominator down here. So I have to multiply the top by x plus 5, and this is distributing. I almost wrote x squared. That would have been wrong. 9x plus 45. So now that I have the same denominators, the numerators must be equal. And let me do a few things at the same time, because I want to subtract 9x to the left side. 4x minus 9x is negative 5x. We have 21, 3 plus 18, but then when I subtract 45 over, I get negative 24 is equal to 0. And at this point, when I go to factor, I get negative 8 plus 3 adds to be negative 5. But as I go to my solutions, I get x equals 8 and negative 3. I've been warning you about extraneous solutions because if you go and you say, well, okay, 8 works, all right? And the reason why 8 works is if you plug in 8 into the denominators, you're going to get fine numbers. The issue is negative 3. So the moment you plug in negative 3 either here or here, negative 3 plus 3 equals 0. So my question to you is, what is 9 divided by 0? Well, that answer is undefined. We cannot divide by 0, and so that's where we get into extraneous solutions. Our answers have to be defined values, and we cannot divide by 0, so negative 3 does not work. Hopefully that makes sense. If it does not make sense, I would encourage you to write down your questions and bring them to class. So I'm going to do the same thing for the next one. It factors out to be x plus 6, x minus 2, so that's going to be your like denominator on each of these. I'm working through this a little bit faster because I'm running close to my end of time. So if you look at this denominator is already fine, so that's why the 4 stays there. But if you look at the next piece, the x plus 6 is missing the x minus 2. So I have to multiply the top by x minus 2. I have to FOIL that out. So x squared, negative 1x, negative 2x is negative 3x. And negative 2 times negative 1 is positive 2. And on the right side, I'm missing the x plus 6. So I have to multiply the top by x plus 6. And it is distributing, but it actually doesn't look any different because 1 times anything is that thing. So now that the denominators are the same, the numerators must be the same. And I need to get it equal to 0, so you're going to see me subtract x to the left side. And 4 plus 2 is 6, but when I subtract 6 over, I get 0 there. And what I like about this problem is it's just a greatest common factor. You can factor out an x minus 4. And then it's a reminder for you that you get x equals 0 and x equals 4. And neither of those are extraneous because they both work in all these problems. You should be ready for the homework now.